In this video, I'd like to talk about graphically dividing complex numbers. And in a previous video, we derived a formula for multiplying two complex numbers when they're written in their polar form. And the essential way to interpret this formula is that multiplying two complex numbers, we end up multiplying their magnitudes and we end up adding their angles, so that we get this new complex number, which if we want, we can call it Z3. And the product of the two magnitudes would be the magnitude of Z3. And this angle here, theta 1 plus theta 2, we can call theta 3, which would be the angle of Z3 relative to that positive real axis. And the approach for dividing complex numbers is very similar. Essentially, we would divide their magnitudes and we would subtract their angles. And that shouldn't be too surprising since multiplication and division tend to be opposites in some sense. So let's apply a similar approach to come up with that formula, where we will take Z1 and divide it by Z2. So let me quickly write in the numerator and the denominator of this quotient here. And the general approach will be to essentially factor out this quotient of the magnitude of Z1 divided by the magnitude of Z2 and focus on these two expressions with cosine and sine in them for both the numerator and denominator. So let me start by making just a bit more room here, and we can start factoring out the two magnitudes, this quotient of the two magnitudes. We have magnitude of Z1 divided by the magnitude of Z2, and we have the expression for essentially the direction of Z1 cosine theta 1 plus I times sine theta 1, and we will divide all of that by cosine theta 2 plus I times the sine of theta 2, essentially the expression for the direction of complex number Z2. And remember, when dividing complex numbers, that the strategy is essentially to get I out of the denominator. And to do that, we want to multiply this denominator by its complex conjugate. So remember, the complex conjugate of a number is essentially the same number, but with the imaginary part having the opposite sign. So we will multiply top and bottom by the cosine of theta 2 minus I times sine of theta 2. And again, we will do that in the top and the bottom here, so that we're essentially just multiplying by 1, since something divided by itself is really just 1. And at this point, we can actually multiply out these two expressions. The bottom, you might notice, is just going to be a difference of squares, but let's actually multiply that out, and we'll rewrite this first part, the magnitude of Z1 over the magnitude of Z2, and up top, we will get the cosine theta 1 distributing into both of those, so we get cosine theta 1 times cosine theta 2, and cosine theta 1 times by I times by the sine of theta 2, and that's a negative number, so we are subtracting I times the cosine theta 1 times by the sine of theta 2, and then we distribute I times the sine of theta 1. And we get plus I times by the sine of theta 1 times by the cosine of theta 2, and we will need to extend this line here. And lastly, we have I times the sine of theta 1 times by minus I times the sine of theta 2, but we will end up with an I squared there, since I times I is I squared. And since I is the square root of minus 1, when we square that, we just get negative 1. So when we multiply these together, we will have a negative sign, but we will be multiplying that by I squared, or negative 1, and those two negatives will cancel. and we will be adding sine theta 1 times sine of theta 2. And now we need to apply the same approach for the denominator, but like I said, this is really a difference of two squares. The middle terms will cancel out, but let's take this piece by piece. We will distribute the cosine of theta 2 into both of those, and we get cosine theta 2 times by itself, which is cosine squared of theta 2. And when we distribute it to this term here, we get I times the cosine of theta 2 times by the sine of theta 2. But we'll get the exact same term and opposite when we distribute I times the sine of theta 2 to the cosine of theta 2. Those will essentially cancel each other out. And lastly, this term I times by the sine of theta 2 will multiply by minus I times by the sine of theta 2. And it's negative, but we're multiplying I times I. And we will once again get I squared, which is negative 1. And those two negatives will cancel. So we just get plus the sine of theta 2 multiplied by itself. So we are squaring that. And you might notice in the bottom that this is a very familiar trig identity. In fact, when we have the cosine squared of some angle plus the sine squared of some angle, this is always equal to 1. This is the simplest of the Pythagorean identities. So this denominator will just be 1. And we can rewrite this expression now. We still have the magnitude of z1 divided by the magnitude of z2, and this denominator is 1, so we just have this numerator. And what we can do from here is organize the real and imaginary parts. Notice we have the real part here and here, and both of these middle terms have I in it, so these are our imaginary parts. So we will write the real parts first, and then the imaginary part second with I factored out. So let me write that very quickly. And once we write these in terms of their real and imaginary parts, we can notice a pattern. And this pattern is very similar to the one that we noticed when we were multiplying two complex numbers in their polar form, and we derived the formula for that. Notice that the real part is really just the cosine of theta 1 minus theta 2. It is the difference trig identity for cosine. And likewise, for the sine function, this is the difference trig identity for sine. We have the sine of theta 1 minus theta 2. And if we substitute everything in, we now have that this quotient z1, the complex number z1 divided by the complex number z2, is the quotient of the magnitudes of these complex numbers multiplied by the cosine of theta 1 minus theta 2 plus I times by the sine of theta 1 minus theta 2. And you can see this is very similar to the multiplication formula. The main difference is that instead of multiplying the magnitudes, we are dividing them. And instead of adding the angles, we are subtracting them. So when dividing two complex numbers graphically, we divide their magnitudes and we subtract their angles.